So good morning, everyone. Welcome to our first Exchange Scheme OpenCall webinar. This webinar aims to clarify the main some questions regarding the first open call for exchange scheme. So for that, for today's agenda, we will have first an introduction of the ENFIELD project by Pankaj, the project coordinator. After that, we will present the 19 research challenges for this first exchange open call. We'll have 6 researchers that will present these 19 challenges. And then we'll explain how can you apply the eligibility criteria and how the evaluation process is done. This presentation will be done by me, Mariana. I'm from Inalva. And finally, we will have a quick Q&A session to clarify any doubts that you can have regarding this open call and the challenges. Just 2 notes before we begin. During this session, you can write your questions in the Q&A tab on top, or if you can use that, you can use directly the chat. We'll have 2 colleagues managing the chat, so they will take care of all the questions to address later on. Specifically, if you have questions regarding the challenges, we kindly ask you to identify these challenges with the codes that we will have on the title of each one of them during the presentation. So first, we will have Pankaj presenting the project. So Pankaj, you can go.
Yes, thank you, Mariana, for this introduction to the project and organizing this webinar. I hope this will be useful for our potential applicants. So good morning, everyone. Well, actually, it's afternoon in Norway now. So before I begin, let me share the slides. I hope my slides are visible to you. Can anyone please confirm that? Yeah, okay, thank you. So my name is Pankaj Pandey, and I'm the project manager for this project ENFIELD. ENFIELD stands for European Lighthouse to Manifest Trustworthy and Green AI. So as the title of the project suggests, the objective of this project is to generate and share knowledge on AI. And we have divided this project into 4 streams and 4 verticals, which I will be talking about. And this is a 3 years project, which started on 1st of September 2023 and will run for 3 years until the 31st of August 2026. And in this endeavor, we will be launching about 16 to 17 open calls under the test scheme. The number of calls may differ, but the objective is to fund the mobility of approximately 76 early stage researchers, which includes PhD, postdocs, and some senior researchers. As well as we will be launching some innovation schemes to fund the applied form of research. So to introduce ENFIELD to you, ENFIELD is a project which received funding from the European Commission under the Horizon program and specifically under the topic called European Network of AI Excellence Centers, expanding the European AI Lighthouse. So as the topic itself suggests, the objective of projects funded under this topic, including ENFIELD, is to be the lighthouse of or the centers of excellence for promotion of AI-related fundamental and applied research. And the total budget for this project is about 11.5 million euros, and the grant received from the European Commission is upwards of 11.2 million euros. The difference between the budget and grant received is because we have one partner from the United Kingdom, and at that point of time, UK was an associated country and was not eligible for funding from the European Commission. Now it has again joined the Horizon program, so but that doesn't change anything for this project. And we the background of this project, like I just explained, is to develop an European AI lighthouse under the specific AI research challenges and promote the generation of research, innovation, and deployment with various stakeholders across the Europe. So it includes academia, industry, SMEs, standards bodies, research and innovation funding agencies, and so on. So to give you an idea of the size of this project, we have 30 partners participating from 18 countries, and which includes participants from industry and SME, as well as participants from academia and research. So academia and research constitutes about 2/3 of the consortium. That is, we have about 20 partners, and 10 partners are from industry and SME. And the logos of all our partners is shown on this slide. We have 30 partners, like I said, mix of several industry and academic partners. And I'm not expecting you to recognize all the logos, but still you get an idea of the type of participants we have, and at least you can recognize some logos, specifically the participants from your countries, I believe. And this project is divided into 4 pillars, like I said. The pillars refer to the streams, you can say. So it's the adaptive AI, green AI, human-centric AI, and trustworthy AI. So these 4 pillars promote research on the fundamental aspects of artificial intelligence across these 4 streams. And corresponding to this, we have 4 verticals, which refers to the industry sectors like healthcare, energy, manufacturing, and space. So the objective of these 4 pillars and 4 verticals is to promote or generate research in the form of, like I said, fundamental research on 4 pillars, and and applied form of research across the 4 verticals to generate knowledge on AI for the European industry and academic partners. And for these 4 pillars and 4 verticals, we have several open calls planned for during the period of this project. And currently we have one open call on the third-party exchange scheme, TESS. Furthermore, we will be launching one open call on the third-party innovation scheme around the June, and please keep an eye on TESS. And a brief introduction of, or a brief description of these 2 open calls is this. So the third-party exchange scheme is to promote the mobility of researchers from the PhD level to some senior researchers level, and the applicants could be individuals or a group of researchers. And the plan is to fund about 76 researchers for a period of 6 months, but this could be for a shorter duration of 3 months. So the period of mobility should range from 3 months to 6 months. And the budget set aside for these test calls for the entire period of this project is 1.1 million euros. And the objective is to promote fundamental foundational research in AI. And for that, we will be launching specific challenges, which will be a mix of 4 pillars and 4 verticals, which my colleagues will be presenting to you in the following sessions. And the objective of this test scheme is to encourage the mobility, or incentivize the mobility by granting an allowance of about 2,400 euros per month to all their researchers. So whosoever is selected for this test scheme and is the individual receive about 2,400 euros per month. I'm saying about or approx because there might be some deductions related to social security or something, depending upon the country specific situation. Now, we currently have an ongoing open call, which ends on 31st of March 2024. And please note the time. The deadline is 5 p.m. 1700 hours Central European time. So don't think that you have time until the midnight of 31st March, but you have time only until the evening of 31st March. So it's better to submit your application as soon as possible. And you can find the application link on the European Union's Europa website, as well as on our project website. And if you cannot find it, please feel free to click on this QR code. And to know more about the ENFIELD project, you can follow us on our Twitter account. And we often post updates on our project as well as our sister projects. And you can also follow us on our LinkedIn profile. And lastly, like I said, that you can keep track of us and the development of this project on our project website. And also the open calls will be announced on the project website in the very early stages. So there's TESS, and now on TESS, like I said, that is to fund the applied form of research. And for this, we plan to fund about 18 small scale projects. And this TESS scheme will be heavily focused on the applied nature. And similar to TESS, TESS also has about 1.1 million euros set aside for this program. And we intend to fund approx 60,000 euros to each applicant. I mean, the selected applicant. So whosoever is selected will receive about 60,000 euros. And that's the plan for this TC scheme. So without taking any more time of yours, so this is the introduction of ENFIELD for you. And if you want to know anything more about ENFIELD or any specific questions, please feel free to drop your questions on the Q&A section, or you can click on this QR code to know more about the ongoing open call. And of course, you can find our contact details on our project website and these pages to approach us for any further discussion or follow-up. Thank you.
Thank you, Pankaj. So as Pankaj was presenting, we'll have 4 exchange schemes open calls during the project lifetime. And in which one of them we will have a different challenge presented for the applicants to address. So in this first open call, we will have 3 challenges per pillar. And in terms of the verticals, in this one, we will not have any challenge for the healthcare vertical. For energy and manufacturing, we will have 2 challenges. And for the space vertical, we will have 3. So in total, we will have 19 challenges proposed for applicants to address in this first open call. Keep in mind that in the next open calls, we will have other challenges that we will address different research topics. So to present, now we will have a presentation of the 19 challenges, which one of them by our researchers. And for questions related to the challenges, please use the corresponding code to identify the challenge. That way it will be easier for us in the Q&A session to address it. First, Eric will present the Green AI topics. So Eric, you can go. We will keep the presentation here and you just need to present it.
Yes, hello. Can you hear me?
Yes, we can.
Perfect.
Good morning.
Thank you. Yeah, so nice to see so many people joining us. So my name is Erik Johannes-Husom. I'm from Sintef Digital in Norway, and I'm going to present the challenges for green AI. First of all, green AI, it's about balancing the energy efficiency of AI models with performance. So not only focusing on how well performing, how good are the AI models, but actually aiming to improve their energy efficiency and reduce the carbon emissions related to AI. So we have 3 challenges related to this pillar. And the first one you can see on the screen now is about advancing green AI on the edge. And the edge, then we're talking about edge devices, resource constrained devices or environments. So we need to adapt AI models to have more efficient use of the data, more optimized models that can be done by quantization, pruning, different types of techniques, and also reducing communication overhead and other various techniques aimed at making AI possible to realize in edge environments. So it's actually a twofold thing, both reducing the carbon emissions, but also making it possible to use AI on smaller devices. And the research activities we plan within this area is to develop resource-efficient neural networks for edge computing. But we're not only constrained to deep learning, it could also be other types of AI methods. In information theoretic approaches, and also one particularly interesting topic called continual learning, how we can incrementally make AI models learn and reduce them needed retraining of models. So what we want to get out of this is at least a peer-reviewed publication, but also to advance the performance of AI models in environments where we have intermittent resources or at least constrained amount of resources. I think we can move on to the second challenge within this pillar. If you go to the next slide. Yes, this one is about optimizing green AI in the edge to cloud continuum. So then we're talking about infrastructures that consists of both edge devices and cloud devices. Could be data servers, data centers, and smaller data centers or devices of different kinds. So in this challenge, we are faced with topics such as balancing the energy efficiency and performance within the continuum, within the full infrastructure, assessing the environmental impact of the full infrastructure or the full continuum, looking into also continual learning for these type of systems. And we also want to look at whether we can develop hybrid AI models where you can merge physical methods or physical models with data-driven methods. So it's a quite open area where we also want to investigate how we can optimize task distribution, architectural decisions to make the continuum more green and sustainable. Yeah, I think I'll just move on to the last one, so I don't use too much time here. The third one is a more overarching theme. This challenge is about green AI metrics. So it's something that goes across all different applications of AI. And here we are faced with challenges such as standardizing and establishing a set of metrics that can be used as benchmarks across many different use cases, and also assessing the full life cycle of AI, all the way from hardware production to operational deployment and end of life. And the more overall theme of balancing energy consumption with performance. So we want to be able to develop a set of universal green AI metrics, both for the full life cycle, but also for specific stages of the AI development process and also the deployment. And we aim for developing tools and methodologies that both can measure these kind of metrics, but also help minimizing the impact. And here again, we want to have a publication out of the work done in this challenge, and also to advance and develop new methodologies within this topic. So thank you for I hope to hear from many of you who wants to work within these challenges, and that's all for me.
Thank you, Eric. We will move to adaptive AI challenges that will be presented by Van Dam. Van Dam, you can start.
Yeah. Hello, everyone. Do you hear me? Yes?
Yes, we can hear you.
Okay, thank you. Very nice to see a lot of people today. So I'm very happy to present a second pillar. It's about adaptive AI. So you know that in real life application and scenarios, we are faced with constantly changing environment with stationary or even non-stationary live streaming data. So the device must therefore be adaptive learner to cope with the changes around them. So this require the development of continual adaptive AI system that are versatile and robust to change in the external environment. So that's the main challenge and the main objective of this pillar. So the first challenge is on the robustness and mainly on the robustness of AI system. So currently, you know that the existing AI system have difficulty adapting to a dynamic environment. So adaptive AI system have to be in situation where rapid changes in the external environment or involving compared objective demand and optimize response. So for this, we have several research challenges. So first one is on robust and secure continuous learning, where we need to be able to have continuously learning from data requires the inclusion of specific constraint to avoid undesirable behavior, such as catastrophic forgetting, incorporating noise data or incorrect label, and so on and so forth. The second research is on the adaptive AI characteristic, including dependability or reliability, robustness, and versatility. And also the adaptability, or it is related to graceful gradations. The third research challenge is is on realization and identifiability of evolutionary model. The next one is on hybrid AI systems, even with continuous dynamics. And then the next challenge is on the multiple modal learning. And finally, it's about the courses classification in dynamic setting. In terms of research activities, we will develop hybrid AI systems and design a new framework for adaptive modeling. And then we need to be able to leverage multiple modality to enhance adaptability of AI systems. And then we try to design also courses classification in a dynamic setting. And finally, to implement adaptive real-time voice conversation and synthesis. So for the outcome or the expected result or that, we hope to have a very good publication in a conference or workshop or journal in the field, and also to advance adaptive continual AI learnings, especially for edge device, which have very limited hardware resources, including limited memory capability and limited computing capabilities. Can you next slide, please? So the next topic is on neuroscience inspired adaptive AI. So it is very exciting and new research topic where we have a lot of interesting scientific challenges. The first one is to identify of the gap between human behavior and AI system we have now, because AI system is still far from what happens in our brain, right? Especially in terms of energy efficiency. And then we try to design some brain-inspired algorithms in order to increase the performance, especially not only energy efficiency, but also other types of performance. We define effective and efficient continual long-line learning because it's we don't have, as I said before, we have data evolution and data change during the application life. We design algorithms learning algorithms, not only based on backpack progression we have now on the neural net, but other kind of learning mechanisms. And also we need to leverage multiple modality from different kind of data set as in the last research area. And then we try to develop sparsity into these deep neural networks in order to increase to compress the model and also to increase energy efficiency. And finally, in terms of robustness and generalization, in this research area is also very important. In terms of research activity, we design neuroscience inspired deep learning architectures in order to make it more efficient and make it smaller. Explore different learning activities and mechanisms to enhance continual learning. Especially use other kinds of maybe another types of learning, not only based on backpack correlation, for example. Explore different modality from data set and to increase the robustness representation. In terms of outcome and expected result, obviously publication is very important in our project. So we target high impact publication in this research area because there are a lot of room for innovations and new research directions. And also we try to advance advance in the multidisciplinary research community. So not only in computer science and data science community, but also neuroscience and cognitive science community in that topics. Next slide, please. No, you pass. Can you go back? And yeah, last but not least is one of the most important research area is adaptive AI on the edge, because mainly a lot of applications now, and especially real life, real scenario or use case are on edge device. So, and for the edge device, one of the main concerns we have here is that we have limited resources, as I said before, so limited memory capabilities and limited computing capabilities. So the first research challenges is about adaptive continual on-device learning, especially we want to develop adaptive continual learning with limited hardware resources related to memory, computing, and also energy. The second research topic is on hardware-aware AI model compressions. So as in the Green AI pillar, we need to compress the AI model in order to run it, to execute it in a real-life hardware platform. So we don't have GPU everywhere. But the compression need to be take into account the hardware constraint related to computing energy and memory capabilities. The next challenge is related to hardware-aware adaptive differential neural architectures. Because nowadays we have a lot of AI model on the stage. So pre-trained AI model adapted for a certain data set. However, for real-life applications, the data set is new, so we don't know how to look for AI model for existing AI model. So this research challenge is to develop a framework that automatically search for a deep AI model on a different hardware types, taking into account hardware constraint and limitations. The next research challenge is on adaptive deep reinforcement learning. So it's about the control policy learning using deep reinforcement learning for the learning environment, in particular for non-standardary environment. For example, a robot will learn how to work on a specific virtual terrain or fail to do so on another terrain, for example. And the last research topic is on the design of specification techniques for including activation, representation, and gradient sparsity. For the research activity, so the first is we will implement the adaptive AI model compression technique for inference on different hardware types. And then we develop an energy-aware model selection strategy in order to look for optimal AI model. The next step is we want to develop adaptive differential neural architectures that automatically search for an efficient deep AI model on different hardware types. We develop also acceleration technique for training by reducing the flops and also the memory usage. And finally, we develop continual learning technique requirement with minimum requirements for retraining, and in particular, continual on-device learning with limited hardware resources. In terms of expected result and outcome, so as usual, so we target high impact applications, but also to advance and to develop new and advanced learning techniques for the edge computing with the hardware limited resource constraints. Okay, is that it for the AI pillar. Thank you for your attention.
Thank you, Vantam. Next, we will have Olivier presenting the human-centric AI challenges.
Yes, thank you. Good afternoon, everyone. I will present the 3 challenges of the human-centric AI pillar. This pillar is interested in the development of novel techniques for and methodologies for creating and evaluating AI-based decision-making systems, focusing on explainable AI, and also transparency, trust, and usability. So in this context, we have 3 challenges. The first challenge is interested in the evolving symbolic models from data based on the interaction between the environment using, for instance, enforcement models, and also with interactions with human beings, with involving human in the definition of template for the symbolic model and or the change of the different parameters. The research activities that are targeted in this challenge are concerned with the study of different symbolic representations, the development of symbolic research methods, and the application of the developed approaches in 2 verticals, that are energy and or healthcare verticals. So the expected results are publications as for the other challenges, and the scientific advancements include the development of the new method for symbolic AI, capable of learning from data, with including reinforcement and interactions with human beings. Next slide, please. So the second challenges is, and these two following challenges are more related to explainability. And this first challenge is interested in the developing a new explainable methods for spatiotemporal models in the context of human action recognition that are challenging issues when we are targeting a video, for instance. So the aim is to develop this explainable approach in the context of using deep neural networks for human decision makings. So the research activities are the design of explainable algorithms for spatiotemporal models, validation of them in the context of human activity action recognition, to explore the model-specific and agnostic explainable model methods in that context, and to evaluate from a qualitative and quantitative point of view the quality of the different explanation, defining some metrics for this topic. Expected results are also here publications, and to include robust explanations linked with high-level interpretations for these spatiotemporal models. It's 2 verticals that are healthcare and manufacturing. So the last challenge is, thank you, is still focusing on explainability in the context of collective data-driven decisions in healthcare, supported by different AI tools. So the idea is to develop and to evaluate how explainability methods could help human beings to take decisions based on AI tools. So the aim is to develop some different metrics for this evaluation. So the activities are related to the design of an explainable decision support system for diagnosis based on medical images, so still applied in the healthcare vertical, to develop an approach to support medical decisions, including performed by different specialists, and to design the algorithms to enhance the explainability of these automatic decisions making systems. Expected results are still publication, and to include these the results of the research in medical domain, emphasizing the transparency and the interpretability of these decisions. So thank you for listening.
Thank you, Olivier. Next, we will have Georges presenting the trustworthy AI research topics.
Hello from me. I'd like to welcome everyone that has joined the webinar. I will represent the fourth research pillar of ENFIELD, which is called Trustworthy AI. And through it, we're trying to do research in every security, privacy, or trust issue that arises through the latest developments and advancements in AI. So for this run of open calls, we have proposed 3 different challenges. The first one is entitled Modeling Trust in Distributed AI System Architectures. Here we look at the problem that arises from the fact that due to the changes in the form of AI, it is common nowadays to have distributed AI systems, AI components integrated into more complex systems that may consist of some AI and some non-AI components, and you always have a human in the loop. So actually adding AI components here and there creates a trust issue and calls for a new approach with respect to how we define, evaluate such trust and how we can establish trust between different actors, maybe competing actors in such environments. The candidate here will do research in one or more of the following lines. The first one would be the creation of a taxonomy of trust and distributed AI system architectures, a specification of a suitable visual modeling language, the development of the required infrastructure for supporting that modeling, the design of the algorithms for automation of the analysis of different systems, and probably the evaluation of trust modeling in distributed AI systems. We hope that through this collaboration between researchers in our pillar and visiting researcher, we will be able to produce at least one publication and have significant scientific advancements with respect to methodologies that try to evaluate trust in the AI context, and also with the development of relevant tools. Next slide. Thanks. The second challenge topic for us is the detection of AI-generated content. We all live in the era of LLMs. We all use more or less such tools. And the truth is that they provide a very efficient setup that can help people do what they did previously in a much faster and much more effective way. But there are cases in which the use of AI-generated content is not wanted, and it may be unethical, inappropriate, or even illegal. For that case, we are discussing the domain of the detection of AI-generated content. How do you detect that this text has been generated by an AI system and not by a human? And along with that, we also focus on techniques that may be used in order to avoid detection. And in general, we hope that we can increase transparency in this in such operations. So the visiting researcher will do research on the detectability of output of currently used LLMs. We'll evaluate the effectiveness of known defense techniques, test current approaches, try to evaluate LLM randomness, report on existing LLM defenses, and even, if possible, propose for novel attack techniques. We again hope for a publication here and advancements with respect to the topic, which is detection of AI-generated content, and also techniques that can help you avoid that detection. Next slide. The third topic, and last from our side, is titled Secure Voice Biometrics with Fake Voice Detection. So it is a bit similar with the previous one, but it's much more focused on voice. And the idea here is that nowadays that we use, in some cases, the voice as a biometric in order to identify someone. Nowadays that we have AI systems that can actually reproduce the voice of someone and use that as the means for an attack to a system. We discussing that in this challenge, what are the required things to do in order to be able to mitigate such attacks. So you need to be able to distinguish between real and synthetic voices. You have to take into account address accent, language, background noise, and voice quality variations. And the end result is that if you focus on all these aspects, you can build a system that would be probably something like an anti-spoofing technique that will help you understand when the voice that you're presented with is AI generated or not. The researcher here will study the factors that affect voice detection. Will research the encryption idea on such data. Will develop new algorithms for anti-spoofing measures, investigate methods to detect fake voice samples, and verify the system's trustworthiness and reliability. Again, we hope for an outcome of a publication, and we expect scientific advancements with respect to anti-spoofing technologies with respect to voice recognition. That was all from the trustworthy AI pillar. Thank you, and I would be happy to answer any questions.
Thank you, Georgios. So now that we present all of the challenge for the pillars, we will get to the vertical challenges. And first, we will have Sophia presenting the energy vertical.
Hello, everyone. Can you hear me?
Yes, I can hear you. Good morning.
Good morning, everyone. I'm Sofia Teocchi from Politecnico of Milan, and I'm going to present you the vertical energy challenges and the manufacturing ones. The first challenge related to the energy vertical is called methods of explainable machine learning applied to LiDAR scan analysis. And it relates to the maintenance of critical electric infrastructure. The research activity proposes the development of an understandable AI model that automatically identifies types of objects from a 3D point cloud in order to identify vegetations and other elements over the infrastructure. One of the main results is a reduction of time between the time of observation and the maintenance intervention. For this particular project, we suggest the usage of a SynNet algorithm as an interpretable 3D point cloud instead of a common convolutional neural network. In fact, the peculiarity of this algorithm is that it uses 11 trainable parameters, reaching a precision gain of 24% against instead of more than 2,000 uninterpretable ones, reducing a lot the training time that is below 1.5 hours and the inference time that is around 20 milliseconds. For this project, we intend to provide to the scientific community 2 publications, specifically 1 conference paper and 1 journal paper. And the potential institution that could host you is EDP, located in Portugal. Next slide. Thank you. The second project related to the energy vertical is called the Coordinated Edge Control of Electric Vehicles Charging at Low Voltage Grid or Microgrids. The main challenge concerns the possibility to solve technical problems in the low voltage grids where when there are multiple vehicles that are charging simultaneously. This project is intended to create intelligent electric vehicle charging strategies to manage charging rates and schedules, considering a lot of constraints such as grid operating conditions, tariffs, and drivers' expectations. For this challenge, we propose a different solution that include green machine learning or federated learning in order to enable distributed intelligence and control at the electric vehicle supply equipment level. The integration of these technologies has as main goal to guarantee data privacy and security, to increase the capacity of the network hosting the electric vehicles, and promoting the usage of renewable energy for this field. The potential institution that could host you is ENFIELD, located in Porto. Thank you. Okay, I'm gonna give the floor for this.
Thank you, Sophia. You will be presenting also the manufacturing challenges later on, but now we'll have Adrian presenting the vertical space challenges.
Hi everyone, from Chalmers University of Technology in Gothenburg on the west coast of Sweden. And as Marianne said, I'll talk about the open calls for the vertical space. And the first one is one you can see here, the fast and accurate atmospheric relative transfer simulations for satellite microwave instruments. And a bit of background to this open call, to the challenge, is that the interaction of our atmosphere and the electromagnetic spectrum, for example, light, is very complicated, but we know very well the physics behind it. These are described by these relative transfer equation. And likely we have computer models that aim to solve this equation, but these computer models have to decide whether they want to be accurate or if they want to be fast. So the scientific challenge here is to use deep learning to try to approximate one of these accurate relative transfer models, but with a fraction of the cost of these precise models, and more precisely looking at the submillimeter microwave region of the electromagnetic spectrum, having in mind some upcoming satellites. Some of the research activities that the candidate can work on during this open call is, of course, the implementation and training of network architectures that should fit the characteristics of this problem. And since this problem is based on physics and we know the physics, we have the question if we can somehow incorporate physical laws in the machine learning process to make the learning or to get better results. And of course, what we want to do here is not just solve the problem, because we know that there exist computer models that can solve the problem. We want to solve the problem more efficiently. So we need to compare with one of these classical fast approaches to see how well we can do with deep learning. So as others have said, it's important for us to get one publication, ideally a conference presentation and a paper in a journal. And what we want to get out from this open call is not only a software that anyone can run, but also to share the knowledge that the candidate and also us can acquire when developing and training the networks model, because we consider that there's little information on regarding this in this field specifically. Next slide, please. So the second challenge, which we titled Generative Models for 3D Cloud Fields, is, again, I will give some physics background, and that is that with a CloudSat, a satellite, which can be considered the gold standard for cloud vertical structures at the global scale, the limitations in the satellite and its instrument limit the use of its data for certain applications. And we've seen conditional GANs trained on CloudSat observations to reconstruct or to generate 2D cloud fields. But we wonder, and these works that we've seen, they've been there for a while, we wonder if advances in the field of generative models can give better 2D, but also 3D cloud field samples. So the candidate in this open call should work with identifying which generative models can suit best the problem, and then, of course, train the models, but we aim for two generative models, in particular an unconditional and a conditional generative model. And we need to make sure that those samples that we get from the model reflect the reality. And as in the previous open call, it's also important for us to get some kind of publication or presentation in a conference or a paper in a journal to share the network that is trained in this open call so that anyone can use it. Next slide, please. And the last slide I'm the last challenge I'm presenting is that of cost-effective precipitation retrievals. So historical rain estimates, that is precipitation retrievals. And we've seen that deep learning approaches have an advantage over, let's say, traditional approaches for retrieving rain estimates in almost immediately from satellite imagery, to be more specific. And we know, and we have an AI approach to do this from one specific geostationary satellite. That's one kind of satellites, where the output of this AI system is a non-parametric probability distribution describing this rain estimate. But in this approach, we have never considered how costly it is to run the network, and also how costly it is to store the results from the network. So that is the scientific challenge, to address these 2 points. So the candidate here should look into finding network architectures that have a small computational footprint and also in the memory footprint, but that can offer a similar performance to what we have right now. And also they should look into, for example, if we can approximate these non-parametric probability distributions that we get as an output with a few parameters, with a handful of parameters from a family of distributions to save disk space, basically. And as before, it's important for us to get some peer-reviewed publication or a conference presentation. And here we really want a software that can be run by anyone, whether that is a scientist or even someone from the, let's say, normal society outside of science, so that they can know how much rain has fallen in the past, let's say, 10 minutes. And that is it for the vertical space.
Thank you, Adrian. So now we'll get back with Sophia to check the challenges for the vertical manufacturing.
Okay. The first topic related to the manufacturing vertical is called the automatic and efficient identification of batch production patterns for tool machine. The idea behind this project is that the dynamic nature of manufacturing operations necessitates near real-time labeling capabilities. And for this purpose, the main goal of this project is to find a way that optimizes maintenance processes for tool machines, considering spatial and temporal distortion, given that only very few patterns are labeled. So the expected results from the candidate include the development of an embedded green AI algorithm that is able to identify different batch production patterns, to characterize the health condition of the equipment, and based on this, to develop condition-based maintenance practices for the considered tool machines. For this topic, publications are welcome, both for conferences and journals, and the potential institutions that could host the potential candidate are the Polytechnic of Milan and Predict. And finally, we have the last challenge, which is called the self-X integration in the manufacturing domain. This is a more practical project with respect to the others that I presented, because it is supposed to put into a lab-scale production a defined and centralized software architecture starting from existing AI pipelines, implementing self-X capabilities. When speaking of self-X technologies, we intend the capability to self-configure, self-heal, self-optimize, and self-protect applied to an industrial process. This has as main results to ensure compatibility and interoperability with the existing legacy systems and the infrastructure, but also the minimization of human intervention through intuitive interfaces and decision support systems, and but also the reduction of disruptions of the existing routines. From this use case, we expect to provide at least one peer-reviewed journal publication regarding the state-of-the-art and the application of the AI architecture into an experimental environment. And the activities will be carried in Polytechnic of Milan. From my side, it's all, and thank you for the attention.
Thank you, Sophia. And I thank all the researchers that present all of the 19 research challenges for this open call. So now we will address how can you apply the criteria of eligibility and how is the evaluation process for this exchange open call. As we said before, the goal of this exchange scheme open call is to support 76 researchers in total. It will be divided in 4 open exchange scheme open calls throughout the lifetime of the project. And this first open call it will be open until the end of March. We will provide a mobility allowance of 2,400 euros. This is a fixed amount for researchers to conduct their experiments abroad in research center from the ENFIELD from one of the ENFIELD partners institutions. Also, the activities to be proposed need to be between 3 to 6 months. So regarding who can apply, so it can be PhD candidates, postdocs, or senior researchers, as long as they are from EU member states or Horizon Europe associated countries. Also, they need to be employed at an academic or research organization in EU member states or Horizon Europe associated countries. PhD candidates need to also to show their enrollment in the doctoral program. And none of them should be connected to or none of the academic or research organizations should be part of an ENFIELD partner institution. In terms of the application, it can be individual or it can be in group. In the case of being in a group, we need to have 1 senior researcher or a postdoc and 1 or 2 PhD candidates. So to apply, you can only submit your applications throughout this link or the QR code that it can go directly to the application page. So we will go through all of in detail through all of the steps of the proposal, but basically when you access this link, you need to answer all these mandatory questions, accept the terms and conditions. You need to add the technical annex and also a presentation video of 2 minutes, and you need to submit the proposals before the 31 of March. So first of all, in the application page, the first thing you will see is to select if it's an individual or a group application. As you can see here, if you select individual application, you will go directly to your personal details. If you select a group application, you will need to give the details of the group leader, and then you will have the detailed information for the team members. Regarding the project details, the second step here is to select the challenge. So pay attention when selecting the challenge that you have a tab here, and you will have all of the names of each of the challenge that we present. And you will select one of these. And when you select one of these, immediately it will appear the possible host institution for that one. So in this case, you will have an example of Adaptive AI Challenge 1, and then we'll have these 3 possible partner organizations, and you can move these boxes to fill in terms of your preference, to choose your preference in between these 3. After that, it's mandatory to add a technical annex and a video link. So first, for the technical annex, you will have the template in our website page. but you need to create a proposal that addresses a challenge to which you are applying. So you need to identify the challenge here with the title of the challenge that you selected to apply. Then you create in your proposal, you need to first create a title for your project. Then you need to have an abstract of your project specifying what are the main objectives, the activities that will conduct to achieve the results for this challenges, the expected results, and the added value to the European community. After that, you will need to explain how your proposal contributes to go beyond the state of the art, how innovative it is, how new. Then you will need to explain the scientific approach, which is basically the methods and the technologies that you will use to address this challenge. We will also have a part where you need to explain how we will disseminate and communicate the results of your proposal in terms of presentations in conferences, publications, other events, and how we would expect that this project continues beyond the duration of these 3 to 6 months. Finally, you will need to explain the competencies and skills in this field of the research or the group of researchers that it is applying to the challenge. Please use the template that we provide on our website. Also, in the application form, you can directly download this Word file. You will have a limit of characters for each of these sections, and do not modify this template or formatting. You just need to save it in PDF and upload it in the web page of application. In terms of the video that you need to submit, basically this is a video that you need to use to present yourself or as a researcher or the group of researchers, and need to explain your motivation to apply to this specific challenge that you choose. This is supposed to be a simple video. It's only 2 minutes, and you need to clearly state what motivates you to pursue this opportunity. As I was saying, you have a maximum of 2 minutes for this video presentation that it needs to be in English. And during the application, you will not upload the video. Instead, you need to have this video online, and you will provide us a link to the video extension where we can access and see the video. So what happens after you submit your application? So then we start this evaluation process. First, in OVA, we will check the eligibility criteria, and in case you don't meet the requirements, you will receive a rejection letter directly. If on the other side you meet all the eligibility criteria, your application will move to a remote evaluation that will be done by 3 independent senior researchers from the ENFIELD consortium. And then after that, they will meet to have a consensus meeting and define which are the applications selected and which are the ones rejected. So in case of rejection, you will again receive a rejection letter. In case you are selected, we will proceed to the assignment of the subgrant agreement, and your project will begin. So getting into details in terms of the evaluation, how it will be done. The first step, it is the remote evaluation. This evaluation will be done by 3 senior researchers from the ENFIELD partner scientific organizations, and they will have 4 criteria to evaluate your your application. Basically, they will evaluate the advanced state-of-the-art of your proposal, the scientific approach, the dissemination and communication, and also the technical and creative capacities. So for each one of these 4 evaluation criteria, the evaluators will score from 0, which means fail, to 5, which is excellent. And then we will have a final score that will be the average of each one of the 5 evaluation criteria. The final score will be given by an average of the evaluation of the 3 independent senior experts. After this individual evaluation, they will meet, the 3 of them, in a consensus meeting. They will produce a consensus evaluation report where they state the selected applications and the rejected ones, with the opinions and scores for which all of the evaluators agree and will sign. Also, these decisions should be done by consensus, but when not possible, in terms of majority, will be done. So votes 2 by 3 will be done as selected. So now we can start with our Q&A session. As I was saying in the beginning, use the Q&A tab to ask your questions, and also you can inquire us for further details or any other question that you have directly throughout our email, for specifically dedicated to the open call.
So we have a question in the Q&A that is concerning the data sets. So this perhaps can be answered by our technical partners. The question is as follows. Who is going to provide industry data sets for training and testing machine learning models performance? Olivier or Sophia, yes, please.
Yeah, from the manufacturing vertical, we have available data sets from a production line or from available robots in our laboratory, while for the energy vertical, there are available data sets. So you have all the data to train all your machine learning models.
Okay, thank you. So we have an additional question concerning who is the PI, let's say, behind each one of the challenges. So the host institutions are clearly identified in the catalog of challenges. So in case you wish to know further information in terms of who is the PI behind it, or the department within the institution that is launching the challenge, please send us an email to the general email account. Otherwise, just point out which challenge you are interested in, and we might be able to clarify it now. This is a question from Neo Christopher Chung.
So from what I understood, all of the questions that were already addressed, all the other questions were already addressed in our Q&A tab. So if there are no further questions, we would like to thank you. Pankaj. Yeah, Pankaj.
Yes, so thank you, Mariana, and entire Innova team for organizing such a nice webinar. But before we conclude, I have a small suggestion. Maybe it's useful for other participants. As you mentioned, we have already addressed many questions in the chat and Q&A section. But probably it would be a good idea to read out the questions and answers for the information to other participants as well, because some other participants may have the similar questions. It's just a suggestion.
They are quite a few questions, so I guess that it wouldn't be enough time to do so. But nevertheless, we would like to point out that all the questions that have been made in the Q&A, okay, will be made available in the website within the page of the OpenCall within the line of FIQ. Okay.
Okay, that's a good plan. Thank you.
So I was saying thank you all for being here in this webinar. If you want to know more information about these open calls and access all of these documents that you need for the application, scan this QR code or go through this link. And follow us on social media to keep updated on the ENFIELD project, how it's going. Thank you so much and have a nice day.
Thank you all. Thank you. Have a nice day. Bye-bye.
Thank you.